your physics class. You see, continue with your previous class. We have already completed the lens formula, lens maker formula. Lens formula and lens maker formula. Any doubt for your side? Any doubt? Any part of it? Any doubt from your side? Lens formula, you know it. 1 by V minus 1 by U equal to 1 by F. Okay? Lens maker formula, you know it. 1 by F equal to mu minus 1, n minus 1, n minus 1 into 1 by R1 minus 1 by R2. Okay? From your yesterday class, any problem, any doubt of those formulas? Shreya or Pita? Any problem from your side? Lens formula 1 by V minus 1 by U equal to 1 by F. V means the image distance, U means the object distance, N means the focal length. N means the refractive index of the denser medium. Very good. R1 means the first refracting surface. First. For the convex lens, this is the first and that is the second. For the concave lens, this is the first. This is the R1 and that is the R2. But for the convex lens, this is the R1 and that is the R2. So my dear student, sir, can't we hear anything? Chinmay sir. Chinmay sir. Chinmay sir. You hear to me? You check it. You check it. You hear me? Orpita, you check it. Yes, sir. Thank you, thank you, thank you, thank you. Okay. Next. Next is this. More noise is coming from where? Windows are blocked, doors are blocked. From where? From the student side it may be. Okay. So next part, magnification. Magnification from your spherical mirror formula, you know it, the magnification for the spherical mirror n equal to minus V by U. Minus V by U. But for the lens, the magnification means height of the image by height of the object, which is the ratio of the height of the image and the height of the object, denoted by the letter M. From the background. Okay, M equal to ratio of the height of the image by height of the object means, you know the diagram PQ by PQ. What is the relation between them? What is the relation between them? You check here again, this is the PQ and that is the PQ. Okay, so and this is the PQ. So it is the ratio of the PQ equal to OP by O capital P. Okay, OP by okay, clear? OP by OP. That means you know it. V by U. You remember it. You remember it. It is the positive. But for the mirror it was the negative. You remember in this method lens has two surfaces. So minus minus plus. A mirror has one surface. So it will be the minus. So minus V by U, and here we write this V by U. Okay. Next is this magnification. The next part is the power of lens. Power of lens. Power of a lens. Power of a lens P equal to, denoted by the letter P equal to 1 by F. It is the reciprocal of focal length. But interesting is this, the unit of the power is diopter. Diopter denoted by the letter D. When it will be the diopter? When you consider the unit of focal length in meter. Unit of focal length in meter, that time the unit of power of the lens is a diopter. So you must be sincere the unit of the focal length of the lens. Okay. Next part. Suppose you consider, you see plus minus 2D. What is the meaning of it? Plus minus 2D, what is the meaning of it? Plus 2D means it is the power of a lens whose focal length is 50 centimeter. Plus indicates the convex lens. You know it. P equal to 1 by F. P means 2. You put here 1 by F plus 2. That is equal to F equal to 1 by plus 2 in meter. That is equal to 50 centimeter. So my dear student, when F is plus, F is only plus for the convex lens. For the convex lens. When F is minus, you consider this minus 2D. That means P equal to minus 1 by F, F equal to 1 by minus 2. That is equal to minus 50 centimeter. That means it is the concave lens or it is the convex lens. So my dear student, you must be sincere about it. You know the ray diagram for the concave and convex lens. So my dear student, you always try to draw the concave and convex lens for the image formation, both the lenses. Suppose you consider it, this, one diagram you know it, this. If this is the F, that is the C, if the object is beyond the C. If the object is placed beyond the C, image will form. Image will be formed in between C and F. Image will be formed in between C and F. If the object is here, okay, if the object is here, the image will be there in between C and F. Okay, so my dear student, you know it. If the object is placed beyond the C, image will form in between C and F, and it will be real and the smaller in size. If the object is placed on the C, image will form on the C in opposite direction, same size and real. If the object is placed in between C and F, image will form beyond the C, and nature is real and inverted and larger in size. If the object is placed on the F, image will form infinity, larger size and real. If the object is placed in between optical center and the focus, means lens and the focus, that time image will form virtual, larger in size, same size. Okay, behind the object. Same side means behind the object. So my dear student, you know it. You must be try to summarize of this chapter. Okay. First you consider the lens, the concave lens, convex lens. Convex lens. First you consider the convex lens. Object distance always u. Image distance always positive. Focal length f is positive. Okay. Next, if the object is placed position, if the object is placed beyond the C, greater than C, then image will form in between C and F. Nature will be a real. Position of image, position of object, C and F, then it will be a real. If it is on the C, means it will be C, a real and same side, smaller in size, less than C, that will be greater than C, a real but larger in size. Okay, less than C means in between C and F. On F, it will be infinity. It will be infinity, real and enlarged. Lastly, you know it, less than C means less than F. Then it will be behind the F object. Virtual, larger in size. So my dear student, you check here, for this case is very vital. U is negative, V is negative, F is positive for this case. So you try to summarize this in this method. For the convex lens, if the object distance always the negative, image distance positive, focal length positive, position of the object, position of the image and nature of the image. For the special case this, when the object is placed in between lens and focus, means less than focus, then the image will form behind the object. That time the image distance will be negative, and the nature of the image will be virtual and the larger in size. Okay, next, the concave lens. You know it, always negative, always positive, always positive. Okay, anywhere, if you put this object anywhere, the image will form in between lens, in between and less than f, in between lens and focus. The image will be nature, virtual and smaller in size. So this is the basic difference between the concave and the convex lens. Concave lens always form the virtual image in smaller in size, but convex lens form the virtual image but larger in size. For only one case, when the object is placed in between the lens and the focus. Okay, so my dear student, you know it, you try to write it, you try to remember it, and from this you also know the magnification, you also know the power of the lens, because power of the lens indicate the plus or the minus. You check here, sorry my dear students, sorry, you check it. This is the diagram for focus and this. So all are negative. So sorry for this. All are negative. U, V and F diagram is this. Okay. So my dear student, because from this you know the power of the lens equal to 1 by F. When F is positive, when F is negative. F is positive for the convex lens. F is positive for the convex lens. When you write this convex lens, F is positive. P is negative for the concave lens. For the concave lens. So my dear student, you must be sincere about it. Plus minus 2D. And when you put it, the value of the power of the lens, that time the formula, conjugate formula for it, you know it, when the two lenses are contact to each other, that time the power of the lens, equivalent power of the lens equal to P1 plus P2, or 1 by F equal to 1 by F1 plus 1 by F2. Okay. So my dear student, one question from your practical base. If the two lenses, one is the concave and another is the convex, but those are the same focal length, when they are contact to each other, what will be the focal length, what will be the conjugate focal length, what will be the conjugate power of those lenses, in lenses. So my dear student, you remember it. If the two lenses, suppose, if the two lenses, one is the focal length f1 equal to 15 centimeter for the convex lens and f2 equal to minus 15 centimeter for the concave lens. Okay. When they are contact to each other, then focal length will be 1 by f1 plus 1 by f2. That time 1 by 15 minus 1 by 15, that will be 0. If 1 by f equal to 0, f equal to 1 by infinity, 1 by 0, that means the infinity, that means the just a glass slab. Just a glass slab, you know it. When the incident ray or incident on that lens, that time no deviated. No deviated means just a glass slab. So due to this laws of refraction, when the light passes through the glass slab, only the rays are parallel to each other. Parallel to each other. Okay. So my dear student, you must be sincere about it. What will be the power of the lens? The power of the lens P will be 0, because you know it, P1 equal to minus 1 by 15. 1 by 15, and 100 by 15, that means P1, one is the positive and another is the negative. Suppose both are the P1 and P2, and P1 equal to P2. So those are cancelled to each other, P equal to 0. F equal to infinity, then P equal to 0. So my dear student, you remember it, the combination of the thin lenses, the equivalent power or equivalent focal length of those combination, and magnification, when it will be plus and when it will be minus. Magnification plus when the image will be virtual. When the image will be virtual. When the image will be real, that time it will be minus. One is this upward and another is the down. Okay. So my dear student, when you see your numericals, that time you see the plus or minus sign, the real or the virtual. Suppose you consider it with the help of the concave lens. Object is here, suppose you draw the diagram. It is coming from F. Another is the passing from the optical center. The image will form here. So this distance is the U, that distance is the V. So M equal to minus V minus U. That means the positive. Okay. The positive means it will be the virtual. Okay. When you see the image is for this side and that side, that means this side is negative and that side is positive. So M equal to V by U. V by U equal to, this is positive by negative. Positive by negative, that will be the negative. My dear student, you check it. So for the real image, it will be negative. For the virtual image, it will be positive. So you must be sincere the sign convention for the lens and the sign convention for the mirror, because when you complete your numerical, that time you see mirror and lens combination numericals may be in your competitive exam. So my dear student, again I repeat it, the sign convention, you must be sincere about it, because you know it from your previous class. Okay? The combination of the lens. Next is the refraction through the prism. And lens, so many types of questions are there. Suppose you know it is a convex lens. The refractive index of that medium is N, and this is the ear. So it behaves like a convex lens because the shape of the lens is convex and the surrounding medium is less than the medium of the convex lens. Am I clear? Because you know it, this is the glass. But if you put it the glass lens means lens made by the glass. But in a medium whose medium is denser than the glass, that time the lens behaves like a concave lens, because if the surrounding medium is denser than the medium of the lens, it will be a opposite lenses. Suppose you consider it water inside the glass. You see so many air bubbles are there. The shape of the air bubbles is convex, but it behaves like a concave lens because the surrounding medium is denser than the air. So my dear student, it behaves like a concave lens. So this type of question for your reasoning or your practical, and last you know it, if the lens is sink inside the water, or when you dip in a water, you cannot see it with the help of your eye. Why is it? My dear student, you know it. When you try to see inside the water, that means when you dip in a water, it's a pond or a river or a sea, you cannot see clearly. You cannot see, but fish and everything says see clearly. Why? Why? This is the very vital question, because you know it. Your lens is set up with respect to air. Your lens is set up with respect to air. That means the focal length, the refractive index of that medium with respect to air. With respect to air, you can see it clearly. But when you dip it in water, that time, do you know it? The focal length f equal to mu n2 by n1 minus 1 into 1 by r1 minus 1 by r2. So this is fixed, no problem. So focal length n2 by n1, when you see the n1 is 1 here, that time the value is 1.5 minus 1, 0.5. So 1 by f equal to 0.5. When you dip in water, that time the value will be 1.33. 1.5 by 1.33 minus 1. So that value will be less. This value will be more. If that value is more, the image will not form on the retina. So you cannot see it clearly. You cannot see any object inside the water. For this reason, you can use, when you dip in water, the special type of spectacles for your eye. And that time you can see it clearly inside the water. So today up to this portion. Thank you my dear student. Next I see you again.